it and do also more minutes. Okay, so then if you find out that 30 minutes, for example, give an error, let me know. Okay, but this one prove the software can acquire long time, at least. This is what I can say. The next test instead is more related now to test how reliable is the Bluetooth. The first test for the software, this is Bluetooth. So we are still in the ideal case. So we use two module which were packaged and built on PCB produced by the manufacturer. So this one should be the best equipment that we can have. We will have the PC connect to an Arduino which will work as a master. So practically is the one that work as a base station which send a message to the slave on the other side. And between the two there is the two Bluetooth module. So these two communicate with the Bluetooth protocol. The master will ask to the slave to send the data acquired, and then the slave will answer with all the data. So to perform this, there are a few steps. The first steps is that the master does not know who is the slave. So he need to send a Bluetooth message which say, hello everyone which is around, let me know if there is anyone here. So for doing that, you have to send one command which is AT plus disk, which is reported in the datasheet of the Bluetooth module. So the PC sends this message to the Arduino which has no microcontroller, which means that the message goes through directly to the HM, but we use the Arduino board. So the message goes through the HM19, and the HM19, which is the Bluetooth, start to send this Bluetooth to all the device around. And all the device around will start to answer. In our case, there is only one device. So this Arduino slave, this HM here, which is connected to the slave, will answer, give him back his own MAC address. The message received is, so if you have many Bluetooth, each MAC address is associated to an index. So for example, the Bluetooth, this one here, is associated to MAC to index 0. If there is another one, we'll have index 1. So you have a list of different index with different MAC address. And if you want, for example, to connect to this one here, which has index 0, you say IAT plus con 0. If you want to connect with another one which has index 2, you write AT plus con 2. Okay. So this one will create a pairing between the two. So this one, once you send this message here, you have that these two are paired. And you will see here there is some LED that turns on at the same time, light always on. Now finally, this Bluetooth bridge is like non-existent anymore. It's like that we connected this Arduino here with this, because now we have the communication. We send again the letter A as we did before, and then this one should start to send all the number from 1 to 255 as we did previously. So the point is that this Arduino here will have the same program that we have used for the test 1, and here there is no microcontroller because we use the Arduino board just to use the circuitry to create the signal from USB to UART. So we don't otherwise. Okay. So now we are going to Arduino again, and I will tell you why. My script here does not actually send these two commands here at the moment. The previous version which I have in my old computer, yes, but this one no. So this command can be sent easily by using the Arduino IDE. So first of all, we have two Arduino now, one without microcontroller, one with microcontroller. The one without is the master, this one is the slave. And we are going to connect both the master and the slave. So this is the slave, this one here. This is the master, which has no microcontroller. We also connect it to the computer. Now we'll see, for example, that we should have two COM, because the master and slave. I don't know now which is, let me see which is the master again. So the slave is the COM8, and the master that I connect now is the COM9. Okay. So now it's important also to connect, these are the two Bluetooth modules. It's also important to connect them correctly. So in the back of the module, there are the meaning of this pin here. So I can also open it for you because so you can see a little bit better. It opens from the front. I just lift this one like this. So in the back there is the name of the pins, so you know what is the function of each pin. So then we put it inside again. There. And so this wire is VCC, so this one wire here is VCC. So I will connect to the, okay, also let's say I have to tell you which is the master, which is the slave. This is the master and this is the slave. So this one, which is the slave, which is because that's the microcontroller, should be connected to this one here. The first one here, if you read then the pin there, is the VCC. So this one has to go to the power supply, and Arduino will give the power supply of this. The power supply can be 5 volt because in the green PCB here there is a regulator which reduces 5 to 3.3. So this one is 5 volt. The second line here is the ground, which is this one here. So I connect also the ground here. And then we have this, the third one, which is the TX. Okay, the TX of the Bluetooth. Okay, this one, it goes to the RX of the Arduino because it transmits from here, and this one should be the receiving pin. And finally, there is this one, which must be the RX for sure. But I can tell you that, sorry, it should be the TX in Arduino because the data come out from here and go to the Bluetooth. But remember that if I'm correct, the signal from the Bluetooth, the data are between 0 and 5, and it's not good to get this one between 0 and 5. So what I did is put a potentiometer, which create kind of like a voltage divider. So if this one is the Arduino here, this is the TX pin. I have a potentiometer, which connected like this, and this is the RX of the HM19. So practically this one is 10 kilo ohm potentiometer. And if this one is set around half or a little bit more, because we want 3.3 volt here, and here is between 0 and 5, here we want between 0 and 3. So I set this potentiometer so I get the voltage. This is why we have these two components here for the two. And yeah, so we connected this. We double checked that also the master is connected correctly. So the first pin here, this wire here, which is the connect to the first, is the power supply, which is goes here, which is this one here. It's 5 volt also here. The second, which is this one here, is going to this wire here. This wire here is the ground. Then we have this one is an extra wire, I don't need for the moment. Then third pin, which is this one here. This one is the TX of the Bluetooth, so it has to go to the Arduino. And as you can see here, it go to the TX of the Arduino. This makes sense because this would be the TX of the micro, but we don't have the micro. So practically the USB, when it sends the data, it sends it to the TX. So practically this TX here is connected to the TX. No, sorry. When it sends the data, the USB, it go to the RX, and when it receive, it come from here. So for the master, just to make it easy, the TX of the Arduino board has to be connected to the TX. For the slave, the TX go to the RX, and the RX go to the TX. So finally, the RX of the Arduino board go to the potentiometer, because it has to transmit here, and then the potentiometer go to the TX. So this is the connection on how to do it. I will also write in a schematic, so maybe it's easier to understand. But this one is set. You can see that you can imagine, how do I distinguish the master and the slave? The master, when these two are powered correctly, is blinking. The slave is not, because remember that this blink consumes power. Okay. So the slave should not blink, otherwise consume power in the implanted module. So this one is blinking because we can consume as much power as we want. And it's nice because I can see that it's powered correctly. So now what I will do is using the, I have to communicate now with the master and give him this code here, because then the master will start to send a Bluetooth scan. So the master is connected to the 9, the COM9. So I have to select before the COM9. To verify that I'm connecting, I have a connection with the master, I can also write just AT, which is just a command that like say hello, and the master should say okay. So if you get okay, it means you have a connection. Now we have to send this command here. Remember that one important thing I didn't say is that here it has to be set correctly. The Bluetooth HM19 send data without any ending line. So usually when you send the data from Arduino with the serial.println, what happens is that you send the data, let's say character A, for example. Arduino send the data, but then it also add an extra character which go in the new line. And if instead you use serial.write, you don't have this extra new line character. So it means you just send the 8-bit of the character. So here is important you send it with no line ending, because there is just the character. And also the baud rate has to be set correctly. Which has to be the same that you use here in the code. And also the same in the software. Here. They have to be coordinated. Okay, so now we send the message for the scan. So AT plus disk, like this. And now you can see the answer is this 0. This is the MAC address of the IMD of the slave. And I call it IMD1. I can assign him a name. So now you can see the index is this one here after this
0.
Yes. So then to connect to that one, I will just do AT plus con 0, because the index here is 0 on the device. Now I send it, and if you will see here, also the slave will turn on the LED. As soon as I push the message, both of them will start to have the fixed red light. Okay? So now I will send it. If you watch it there, now they are all both fixed, which means they are paired now. So we create the link. Now we don't need any more Arduino because we already sent these two messages which are not in my software. We have to close that because the Arduino now is making busy the COM9. So we have to close it, otherwise the software cannot find the COM9, which is free. And now we run the software. And remember that in order that to the slave to send message, we still have to send the character A. So we have to go up and select this one here. And now as soon as I click, the slave will start to send message. And we can plot it in our figure, ideally. Because now I send that, but you can see that I don't get any plot. And if we are going to troubleshoot, you can see that the slave, which is this one, is not sending anything because the LED here, TX, is not turning on. If it was sending, then you would see that one turning on. So now there is something, I think, oh yeah, the reason is because this one was COM8. I should have changed it to COM9. Because the master is at the COM9. So I restart the software. And I will send this right. Let's start check now. There it is. Now you see there the LED. And now I'm getting the data there. Oh, I think I was 60 seconds, so we have to wait. Okay, now we reach 60. The slave is continuing to send, and the master continuing to receive, but we don't have anything more to plot, so we just disconnect everything. So we just do like this, so MATLAB does not go in overload. Okay, now we have plenty of data, even more than what I wanted, but we can go to check now the data little by little. And here we will see something interesting and something that we have to actually try to analyze and start to, yeah. So let's see, for example, for the first second here. So you can see here it seems pretty nice again. It seemed to start pretty okay. We have all the data that we need. Let's see. Okay, let's go back to maybe 1 second still. But also visually you can see there is something interesting.
Artifacts, like
3, 4, 6, 7, 7. Let's say here. I think here it start. Although it doesn't look so visible. Nah, this one no. But you can see there are some. Let's still consider here 1 second because they should be here. You can see me that it is a bit more darker there.
Mm-hmm.
And now we see there is something interesting here.
Mm-hmm.
So there is a type of error that we could have, which show that, in my opinion, what I can deduce is that whenever we are going toward 255, then we can have this type of error here. So the error say that it goes between 0 and 255 multiple times, and then it start again normally. But the error is not presented here. It look like present only at the end. I cannot generalize, so to generalize I should also watch the other period. So let's say another interval here, for example. Let's say here.
Mm-hmm.
Let's say this random period here. You see the error is always present at the end of this ramp. So every time you reach the 255, you start to get this type of error here, or a little bit earlier. So it looked like that the Bluetooth module, it has some error that can happen, not all the time, but periodically, every time you reach 255.
Mm-hmm.
So this one, it means that the system is affected by a certain error rate. So in 2 million data, maybe 100 or 1000 they are corrupted.
Mm-hmm.
This one is the error rate. So to characterize the Bluetooth module, we have to say how many bits are corrupted in respect to the total, and how this one affect the system. Is this one something important? Is this one something that we can neglect, or we have to try to understand from the data that we acquire? From initial inspection, I would say, okay, it looked like that the error is at the end when we have data around 255. So if actually my signal changed in this range, I should not have any error. But this one's assume that the error is created again when we reach 255.
Mm-hmm.
The interesting thing is to understand now the system is created by different parts. Which is the part which actually introduced the error? Does come out during the Bluetooth? Is it the Arduino slave which sent an error? Or is it the software? Okay, with the test one, we already saw that the software is okay. And also the slave is okay. But the slave was not connected to the Bluetooth module. So it's possible that by loading the Bluetooth module in the slave, maybe we'll lose some data. Remember, when you have a source, you put a load, you affect the source. So then we also have to recheck that the data sent by the slave connect to the Bluetooth. So we measure here if the data are all okay or not. I already done that, but we can do it again together. And I observe already that this actually send data correctly. So the only option then is that the error come here. And when I measure the data at the receiver, in fact, I saw that there is the same error that this. So my guess is that there is some loss here. I did a few tests. For example, you know that the antenna is in here. So my hypothesis was that the radiation is good in the front of the antenna. And in this side, it should be kind of the worst. So now they are parallel. So maybe it's this one the issue. So I try also to put the Bluetooth in front, but the error was almost similar. So it means that actually it's not that. So there is a study that we should maybe do it to understand what is the clear source here and if we can actually solve it in some way. We have to try to perform some tests. For example, on yourself, you can also try to measure again the data here change the position and see if you can solve actually this. I will also think about it, but maybe if you have some times to also look about this and have some guess. But again, I don't think that it come from this one nor the software, because we tested before and I also measured the data here. I also measure when the micro is connected to this one here, so the load effect is already taken into account. So I think you don't have too much concern about changing the code about this, because these two parts are correct. It's more to understand, reading also maybe the data sheet of these two, if there is something that we miss to take into account. Another thing that I was thinking is that, okay, this one may be due to the fact that the power that this one sends may not be enough to reach this. So it's possible to actually also change the amount of power of transmitting wave of these two devices by sending some code like this through the Bluetooth. You can change the configuration inside. So we can also try to do that. I think this is the